Hi, today I want to talk about how to replace the LED driver on a MacBook Pro or a MacBook Air that use a ball grid array LP8550 chipset to boost the backlight voltage. So on older machines they use the QFN package, which is a lot less scary to people than this one, which uses a BGA package. One of the common things that a lot of people ask is, how do I replace this? How do I reball the chip after I take it off another board so that I can use it on mine? And what I have to say to you is that you're asking the wrong question. The right question should be, how can I spend $2.50 to buy this chip with the balls already on it? You are asking the wrong question if you're trying to reball the chip that you can buy new, pre-balled, for $2.50. Either A, you are just a cheap fuck, or B, you are simply ignorant as I was at one time, and you don't think that you can buy this thing new. But I assure you, if you go to mouser.com right now, that's mouse as in the little thing that my cat kills when he sees it running across the floor, with an R at the end, mouser.com, and search for L as in Lewis, P as in Peter, 8550, LP8550, you will find this IC. It will be about $2.50, and it will come with balls already on it. So you don't have to care about reballing the chip. Am I going to show you how to reball it? No. Do I know how to reball this chip? Probably not. If I tried, would I be able to do it successfully? Maybe. Maybe after a few hours, or maybe after a few hours I'd fail. I don't know, because I never took the time to try, because it is worth it to me to spend $2.50 to get this thing new with balls when I'm charging hundreds of dollars for service. Now that we've gotten that out of the way, let's go on to the actual soldering of the chip. Because for some reason a lot of people find this very, very hard when it should be very, very easy. The hard part is not in soldering the chip. The hard part is in figuring out why my soldering station is not on. And I should know the answer to that by now. I should very much so know the answer to that by now. It's because I'm doing a video. So, motherfucker. There we go. Now, let's wait for that to heat up a little bit. So this is a MacBook Air motherboard. It's an 820-3437. Now this video is mainly going to be on how to actually do the work. I'm not going to go into the diagnostics. I'm not going to go into the schematics. I'm not going to go into all that, because I've done that before in other videos enough. Right now, I just want to show you that replacing this is possible, that you don't have to be a genius, that you don't have to have some fancy schmancy shit to do it, that you can just do it with any old hot air rework station and soldering iron, and that you don't have to reball it, and that it's easy. Because a big problem with all of this work, a big problem with all this stuff, is that people make it seem so hard. They make it seem like it's so impossible. They make it seem like you have to be so cool and so experienced in order to get any of it done. And you don't. You really don't. You just have to have some common sense, and you have to have somebody who already spent all the time figuring it out show you, so that you can do it. And once somebody's shown you how to do it, it's not that hard anymore. So since I don't want to inhale solder smoke and die a terrible death of lung cancer, I'm going to put this nice little Hacko FA430 fume extractor next to where I'm going to be working. Okay, so I have a Hacko FR801 rework station. So the first thing you should know, before you ask me what temperature I'm on 6.5. I spent $200 less to get the Hacko that had analog temperature control instead of digital temperature control. Because the temperature I'm at, I don't care. I will get used to where I am on the knob versus an actual number. And the number that you use is going to be different based on the nozzle you use and all this crap anyway. So I figured I would save $200 on my tool by buying an analog one. So if you want to know what temperature I'm on 6.5. And I'm on about 10 for airflow. So, with that said, let's get on to removing the LED driver. Now, to remove the LED driver, I take my hot air, I'm going to take my tweezers, this broke-ass pair of tweezers, and my good pair of tweezers were probably stolen by my coworker, which is karma because I always steal things from him. And I'm going to do this. So I'm going to be about, I don't know, however far away that is. Now the thing I'm going to do with this chip, I'm going to tap it every now and then to see if it's actually ready to be moved. So the first thing is I want to preheat the board a little bit. You don't want to just like go in on the chip immediately. Preheat the board around it a little bit to make it easy. And And then after a while, when you see the resulting solder, like see that, and see how that's kind of starting to move around a little, then you can go in, touch the chip. Not ready to go yet. Not ready to go yet. Still not ready to go. Now it's ready to go. See, I moved it and it moved. See, the thing that moving it does is it tells me that the chip itself is disconnected from the balls. Because if I just pick this up and any of those balls, what this tells me when I poke it and then I see it move is that every single ball is disconnected from every single pad, and that every single one of those balls is melted. If the balls are not melted, and stop it, I know some of you are laughing right now, if the balls don't melt, if the balls are dry, what they're going to do is they're going to rip those pads off of the board, and then you're going to have to run trace wires to the components underneath the chip that has 25 balls. That's about 1/8 the size of my pinky fingernail, and you don't want to do that. So poke the chip a little bit after you're heating it, poke the chip a little, and then once you've poked it, if you actually see that it moves, not just a tiny bit, but the entire thing can move, make sure your heat is there, keep it there for another 2 seconds. The reason I say keep it there for another 2 seconds is because if you poke it and then you go to remove it, what's going to happen is when you poke it, you probably move the hot air away, which has actually allowed it to cool. So put it back there again for just another 2 seconds and then lift it up. Or even better, you could simply keep the hot air there and not move your hands when you poke it. Don't be like me and move your hand without realizing it when you poke the chip, because you can't control your left and your right hand at the same time, and just remove it. Now, the cleaning stage. What you're going to want is a flat tip soldering iron for this part of the project. So there are different types of tips that you can get. I'm going to show you under the microscope. So you can have a conical tip like this, which is all the way around the same thing. And then you could have this flat chisel tip, which is perfectly flat at one point. We want the... oh my god, this iron can be annoying sometimes. I want to talk and finish my sentence, but no, it's beep. Fuck you. Okay, so let's wait for this thing to heat up. Now, it's going to beep when it heats up. So it's going to allow me to lay this there perfectly flat in order to clean everything. So the first thing I'm going to do here is add some flux. So the flux that I use is Amtech 559. It's good stuff. I have it in one of these nice little syringes. Now I have the wrong syringe, so too much flux is going to come out because I haven't taken the time since moving to find where I'd put my syringes. So I'm just going to put some flux here. And what I want to do is I want to remove all that old solder. All that solder is lead-free solder, which is a little bit more difficult to work with and pick up. Also, it's old, crusty old solder, and I don't want that. I want some nice, fresh, new solder. So what I'm doing here, trying to do here with one eyepiece, is add some like so. This is a nice leaded solder with a good flux. Add it all around. Now what I'm going to do is I'm going to take some solder wick. I like to use Goot wick, spelled G-O-O-T. You can... It's a good stuff. I'm not the biggest fan of wick. I usually use the desoldering iron, the Hacko 808 that I have here. But I don't feel like plugging it in right now. And realistically speaking, most of you guys are going to be more comfortable buying a $5 wick than you are a $200 desoldering gun. So, what I'm going to do is I'm going to put the wick on top of here. Now that I have a flat tip and not a conical one, it's going to be much easier to picking up all the junk. Now what I'm doing is I'm not moving the iron, I'm moving the wick back and forth because it helps control the iron and helps me move where I want it to. And one of the other things with wick, never take the iron off and then move it. Because here's the way this works. This is really just kind of a bunch of braided wire that's designed and put together in a manner in which it absorbs solder. So if I put this on the pads, and then I take the iron off and then I move this, the pad and the solder and this is going to get dry, then it's going to solidify, and this is going to be stuck and soldered onto the pad, and I'm going to move it, and the pads are going to get ripped off. So never, ever, ever move this shit without having the iron firmly pressed on it, and without the iron actually being hot. That's the second thing. So now I'm going to go over this again. Just cut off the little bit of wick that I used. And we're going to make sure that we've got a nice flat surface here. Okay, nice flat surface. And you don't want to go nuts with this part, okay? Another mistake that some people make who are bad at this, and I'm not the best at soldering, but I know enough to not destroy things, is what they do is they overwick it. They get obsessed with cleaning every single little piece, and what happens is they actually wear the pads away to the point where they can't solder to them. I used to have somebody here who did that with graphics chips. You know, half of the graphics chips that he did wouldn't actually work because he wicked the hell out of it. I would wonder, why is it taking 7 or 8 hours to do one job? And then I saw how much time he spent wicking it, and then I started removing some of the graphics chips off of the boards after he was no longer working here, and I saw that a lot of those pads were just gone. And they were covered in this junk. And one of the ways I was able to fix it, by the way, it's a good thing that you should know in case you ever make this mistake, because I've made it before too. If you see that a pad is almost gone after you've wiped it down with the alcohol and everything, put the iron on it at a temperature maybe 750, get a good Kester leaded solder with some good flux inside of it, because they make these with flux. There's some good flux inside that you can get on Allspec, and just keep running solder into it, move it around like this, and you'll notice that what it does is it takes all the crap that was on the pad, all the junk and all the garbage, and it actually winds up getting stuck inside the flux, and it goes away. It pretty much flows away into that solder ball. So when you flick it away, you actually wind up flicking away the crap, and you have a nice pad, and then you can wick it again, and you'll see that it's clean. But hopefully you don't get to the point of doing that. So now we have a nice clean pad. So what I'm going to do now is put some flux on here. Probably too much because I don't have the right little needle. Somebody on YouTube is going to troll me for it. And I'm probably going to tell them to go fuck themselves. So, we're going to get a LP8550. Now again, Mouser.com. How do you reball the chip? What is the proper way to reball the chip? The proper way to reball the chip is to buy it with the balls on it, which is $2.50. Now, another important thing here is to remember the orientation of the chip. Remember the way you took it off of the board, because if you put the chip on the wrong way, it will not actually light up the screen. So you put it on. Now, aligning this is a bitch if you don't have a microscope. So the other thing I should have mentioned here, buy a microscope. This is from Omano. I got this set up for $300 or $400, close to probably $450 or somewhere around there, on Omano's website. I like it. I've often talked about the AmpScope SE400. I don't like that anymore after using this because the image quality on it is not as good, and I like the light that this comes with better. It's a whiter light than the AmpScope lights, because the AmpScope one is like a little, crappy lamp on that thing because it's cheap, and on the higher end ones it's something that's really, really blue. I don't like that super cold blue. So it's totally possible to do this without a microscope, but I don't really recommend it. So, my chip is placed. It's not perfectly square, but it's close enough. You want it to be close enough that it could slide into place without touching other balls. So again, see how it's not perfect over there? I'm going to try my best to get it as perfect as possible. The thing is, it's never going to be totally perfect. So, but that doesn't matter. It's going to slide into place, and I'll show you. Now, the thing is, you don't want to get this too close up on it immediately because it'll fly away. And let's see if it flies away from me here. It eventually will fly away for you. So I'm heating it, I want to preheat everything a little bit just so that when I actually go to solder it, it solders nicely. Now when I go close in, I'll be able to tell once I solder it because it's going to move a little. And you'll see. Okay, it moved a little. 5, 4, 3, 2, 1, 0. Okay. So once I saw it move a little bit into place, and once I started moving my iron in a little circle, and I actually saw that the entire chip was moving, it wasn't just one move like I blew it away with air, but it was moving back and forth like it's sitting on a bed, on a water bed, which is pretty much, a bed of a bunch of wet solder balls. Once I saw that, I knew that it was liquidus under the chip. Liquidus means that I've melted all the balls underneath the chip, and that because all those balls are wet, that whatever's on top of it will be able to move back and forth. Once I saw that, I said, I'm going to keep it here for a few seconds just to make sure all the balls melt. Because you could have a couple of balls melted, you could have the side ones melted, but the middle ones won't be melted. So just because you see that you've melted solder does not mean that you're actually done with ball grid array rework, because the balls on the side are going to melt sooner than the balls in the middle. So once I see that it's moving back and forth, I'm not just happy. I want to actually see that it's going back and forth a couple of times so that I know that I've melted the center balls. But I don't want to keep it hot long enough that I actually burn the chip. And if you see chisels on the corners of the chip, if you see that it's chiseling in any way, then it's no good. Now, if you actually chisel the chip because you touch it with the tweezers too hard, or you scratch the chip, it's okay. If you scratch the chip, you're okay with tweezers on the outer part. But if the chip looks like it's broken off or chipped solely from heat, not from you scratching it, but the heat itself has actually destroyed it, then you fucked it up a little bit, and it's time to move on to the next one. Which again, very, very good thing that this chip here costs $2.50, so it's no big deal. And let me show you what the balls under it look like a little bit. That still has got some alcohol in there, so let's just get rid of that. So I'm going to lower the heat on this to something that won't melt solder and put the air up. I want to be able to evaporate the alcohol away without actually melting the chip. Just to make it easier for you to see. So as you can see, it's a good soldering job. The chip itself is still in good condition. And as always with these videos, I do not do this shit and then edit it and then put it together with a machine that works later, or do this on shit that already worked. I'm going to actually put this in a machine and show you that what we did worked. Because if the stuff that I do doesn't work, you should not listen to my advice. You should only listen to my advice if the advice that I'm giving you is proven to actually work and actually end in a product that you can charge money for. Let's just put this into my test bed machine so that I can show you that we have a perfectly working backlight. Also, as to why we replaced the LED driver on this one. So, there was a short on the backlight output to ground. And when I put some voltage there to figure out where it was, the LP8550 got really hot, which indicates that the backlight driver, the LED driver, was shorted to ground. So I replaced it. Now I haven't actually made any other measurements yet. So there is a very good chance that this doesn't work. I'm just hoping that this is going to be an easy one because I want to be able to do a video where instead of troubleshooting everything, I just go through the basics of how to solder this particular part. But this is a video, and as I've explained previously, anything that I try to do for a video doesn't work. I'm not sure if you can see the blinking question mark or not, because I'm looking into a 2-inch screen for a camcorder. Wait a sec, that's what zoom is for. I forgot, I got a good camcorder now. Okay, so as you can see, our job with the LED driver is now done. So, if you have any questions, post in the comments. I will try to get back to them at my convenience. As usual, you can message me, you can send comments here, but do not call me. If I get a phone call saying, I saw your LED driver video, and I had a question about soldering the ball, no. I'm busy. I got work to do. But if you have any questions, I am more than happy to get back to them at my convenience. If you can ask them in the comment section here or in YouTube messages so that it's something that I can get back to, as my schedule allows.